Welcome. Thank you for viewing my presentation on Cox Automotive's journey from API silos to a unified API strategy. My name is Brendan McNichols, and I'm Senior Director of Architecture in Cox Automotive's Data Solutions Group. A little bit about Cox Automotive. We provide technology solutions and services that cover every part of the automotive industry. The logos at the right are only a fraction of the brands you might recognize, and you might recognize a couple of our brands, AutoTrader and Kelley Blue Book, even if you're not an industry insider. But even if you've never heard of us, if you have purchased, sold, financed, registered, serviced, or even just looked at a car online in the past 20 years or so, it is extremely likely that you've touched at least one of our systems, if not multiple. Because of our product breadth, we have an enormous amount of data on every aspect of the automotive industry. So Cox Automotive has grown by acquiring the best companies in every segment of the industry. While this is great for our position in the market, it presents a significant challenge when we want all of those individual companies to work together. Each of the systems created by those brands were built using different technology stacks. Name a random software development technology, and I'd bet good money we have it somewhere in one of our systems. Each of the individual companies had their own unique culture before acquisition, which, of course, resulted in different standards for just about everything. On top of that, there is a lot of duplicated functionality across the systems, which is particularly difficult to deal with when similar things are done in multiple different ways. And most important, to me at least, is that each of these systems describes the data in sometimes radically different ways. We have data objects that have the same name but have a different purpose, and some that have the same purpose but are named differently. And to make matters worse, even data objects that describe the same thing are practically guaranteed to be defined in a different way. Here's just one example of what I mean. Even describing something as seemingly simple as year, make, model, and trim yields a surprisingly large number of different permutations of all the ways of describing the object. The objects themselves are named differently. Fields are also named differently. Types are different. Type sizes are different. A year represented as 2 characters versus 4, for example. A field that is required in one definition is optional in another. And frequently, the entire structure is different. And literally every identified object has all of the above issues. So you can probably see how this makes things difficult when we group these systems and try to make them work together. But we need to try. Not only does it improve our operational efficiency, but our customers demand it. But how can we make that happen? In the next few slides, I'll talk about the significant things we did or are doing to make it all one big happy family. The first thing we did was to create a group in the company with the goal of unifying our data. We collect data from across the enterprise into a data lake and data warehouse that can be used by our analysts and data scientists. But that platform isn't just for them. It's also used by both our individual brand names and external partners to create new product features or enhance existing ones. This happens in multiple ways, either using the raw data, curated data sets, or highly refined data products created using advanced data science techniques. And finally, there is MLOps as part of the platform to help our data science team use the data in the data lake, and also makes it easier for them to work together with the engineering teams to build new products. But just that alone isn't enough. it can be difficult to make sense of all of that data and organize it so that we can use it effectively. The second thing we did was to make sense of all of that complexity was to adopt a business capability modeling framework. This has helped the situation enormously as it highlighted the places where we had duplicated capability or gaps in functionality. This turns out to be a very important step in the process. Once we discovered those duplications, it made it easier to understand how to organize the company around those capabilities. We could now assign those capabilities to a single group who will work towards converging the functionality to a single implementation that will be consistent and correct across the enterprise. This not only led to a new business architecture, but also a software architecture where these capabilities are packaged and can be composed into complete solutions, both within the company and potentially sold to our customers to use in their own solutions. As it turns out, the Data Solutions Group was creating PBCs from the beginning, although we didn't use that language to talk about them. And the main way that PBCs interact with each other is through APIs, which leads to our next significant change, which was a big evolutionary step in the way we manage APIs. The first part of that was creating a centralized API management platform. This improved our operational efficiency because now our APIs are collected into a single discoverable place with consistent documentation. Of course, that's a less significant achievement if all your APIs use different auth methods and credentials. So unified auth was included in the API management platform. However, the platform is very REST-centric, and REST does not improve the ability of endpoints to be composed to accomplish a larger task. Furthermore, this effort was viewed largely as an engineering responsibility, so there was not much product direction given on how each of the APIs should be designed to work together. All of the ontology problems I described earlier are present in spades in our APIs. So this led to the next step of convincing our product leaders that they should be taking an active role in API design. The overwhelming view of our product team at the time was that APIs are used by engineers, so we'll just let engineers design them. But when your products are PBCs, APIs become the user experience. Just as no sane product manager would ever allow engineers to design a GUI user experience, you probably shouldn't leave it up to them to design API user experiences either. We needed to take an approach where product managers are leading, or really co-leading along with architecture, the design of APIs to ensure that each individual API works appropriately in the larger context. Furthermore, this led us to the conclusion that we need to have some form of governance, or stewardship to use a less scary term, because APIs cannot work together without a common schema. So how can we solve this issue? We can do it with the final piece of the puzzle. The answer was obvious once we thought about it. We needed to build an additional platform based around GraphQL. We did a thorough evaluation of the options out there and concluded that the market leader in this space, Apollo, is the right choice for us. The killer feature of Apollo's GraphOS project is federation, which puts your individual APIs into a single graph, but still allows those APIs to continue to evolve largely independently. Furthermore, in order to use multiple REST services to accomplish a task, we need to write complex orchestration code on the client or create specialized backend for front-end services. We no longer need to do that with GraphQL Federation because it will handle that orchestration automatically. In addition to handling orchestration, GraphQL Federation also forces the API designer to do at least a minimum level of governance. This means that we can no longer ignore the problem because it's hard and we just don't want to think about it. Apollo's product goes even further and introduces some features to make governance process easier. And finally, GraphQL Federation makes it possible, perhaps even easy, to do product analytics on our APIs so that we can make data-driven decisions about how to evolve the federated graph over time. So that's all awesome, but how is it going? Well, we're still in the early stages. The Data Solutions Group is building out the platform and learning how to operate it. Late in 2023, we acquired a license for Apollo Graph OS and hit the ground running with the centralized platform team. That team already has the GraphQL Federation infrastructure running in our production environment. We created a governance squad that consists of software architects, product leaders, and some engineers that quickly put into place a lightweight process and is learning rapidly how to run that process as efficient and doesn't unnecessarily slow feature development or stifle innovation. We have added product analytics to the team to standardize our methods for understanding how clients are using the federated graph. 4 of our most valuable subgraphs are already integrated, and we are currently onboarding our first clients. Besides the initial successes that I outlined in the previous slide, we've already learned some great lessons. First is that we've recognized the need to have a single product owner for the supergraph. We're currently working where each subgraph product owner needs to work collectively with the other subgraph product owners to manage the overall supergraph. This way of working will not be sustainable as the supergraph grows and the complexity of subgraph interactions increases. From the beginning, we suspected we would need a single product owner, but wanted to make sure we didn't hire prematurely. The second lesson is that we'll need to make governance an official job responsibility. Relying on our current team of volunteers will cause delays in governance activities as we get more requests and the team members get busy in their everyday job responsibilities. We're currently on track to get all our data solutions owned subgraphs integrated in 2024. After that, our plan is to merge the platform team and governance responsibilities in with the enterprise-level API management so that we can have a comprehensive API platform and can start bringing in subgraphs from across the company. In summary, just follow these 5 simple steps. Unify your data, converge to consistent ontology, unify your APIs, get product management involved in API design, and federate your APIs with GraphQL. If you do, you'll be well on your way to unifying your organization before you know it. And with that, we've come to the end of my presentation. Thank you very much for viewing, and I hope you learned something valuable.